My name's Scott Allen. I have a lot of materials to cover, so we will just commence the talk. First, I want you to think about the lighthouse here in this picture. It's obviously facing some adverse weather conditions, and someone had to make a choice about how to build that lighthouse. If I was building that lighthouse, I could have gone out in the water, hammered a pole into the ocean floor, put a light on top, ran an extension cord back to my house or wherever. And that would be a lighthouse maybe, but it wouldn't be very resilient. But it was very cheap and inexpensive to build. If you want resiliency in a lighthouse, then you have to start thinking about drilling into the ocean bed and using concrete and steel and battery backups and things like that. It's obviously a lot more expensive. So this may be obvious, but I just want to point out that the amount of resiliency that you want in a system is more of a business decision than a technical decision. You have to figure out how much downtime can your business incur, how much availability do your customers expect. And then you need to apply some engineering constraints and do some technical research to figure out what can we provide for the right amount of value. So the techniques we're going to talk about today are really for resilient services, which is about maintaining high availability, not perfect availability, high availability. And a lot of the techniques that I'll talk about also apply to disaster recovery. So if an entire data center goes offline and takes your data with it, how do you recover from that problem? Because in both of these cases, to maintain high availability, to have a good disaster recovery plan, you typically need things like redundancy. You need to replicate data to different data centers. But I'm going to focus on the high availability part of this. Disaster recovery would be a different topic. So I'm going to focus on talking about specific Azure features that give you resiliency and high availability. And one of the things you have to do if you're going to decide to move to a cloud is you have to go to that cloud provider. You have to figure out what they offer, what services they provide, how much resiliency is inherent in that service. And I just want to give an overview of some of the services that I've been using in Azure over the last year. So there's compute services. These would be virtual machines or containers running on a virtual machine. Everyone uses storage in Azure. Everyone uses networking to some extent in Azure. There's platform services, integration services, app services. So if you're not familiar with Azure, an app service is something that you can use to deploy a web application, but it's a platform as a service feature. So instead of running a VM, you're just running on a platform. And yes, behind the scenes, it's Linux or Windows, and it's running an IaaS server, but you don't really care about operating system updates and so forth. But that brings up one of the first considerations for building resilient services is, let's say I build an ASP.NET application or ASP.NET Core application. There are several different ways that I could deploy that into Azure. And I want to evaluate my choices if I'm really focused on high availability. For example, I could take an ASP.NET application and easily provision a set of VMs inside of Azure and deploy onto VMs that have IaaS installed. I could also take something like an ASP.NET Core application and deploy it in a service fabric cluster, which we'll talk about later in this presentation. And I can also take an ASP.NET application and deploy it as an app service. So 3 different services, all of them can host web applications for my customers. All of them have different perspectives that you need to take for availability, different techniques that you need to use to make sure that that web service stays up and running. Those are the kind of topics that we'll talk about today. Each of those resources, talking about availability, will also have a service level agreement. And in Azure, it's very easy to do a Google search and say, tell me the service level agreement for app services or for virtual machines. And you should land on a page where you can click on a link. And without very much legalese, Microsoft, on the very opening paragraph of that page, will make it very apparent a couple different things. First of all, for the resource that you're using, like a virtual machine or an app service, what is the expected uptime? What is the guaranteed uptime that Microsoft gives you? That's one piece of information. Second piece of information will be under what conditions will they guarantee that uptime? So for example, for storage, depending on what you select, you might get a guaranteed uptime of 99.9%, which is about 10 minutes of downtime a week. But depending on your configuration, you can also go for 4 nines or 99.99% uptime for your storage. And that would be 4 minutes of downtime a month compared to 40 minutes of downtime per month. The difference is that the 4 nines, 99.99%, require a configuration that is about twice as expensive as 3 nines. So right there is a decision you have to make. Do I want to pay to reduce my downtime by an order of magnitude? The other thing that the service level agreements will tell you is the amount of credit that Microsoft will provide if they do not meet those guaranteed uptime statistics. Another thing to understand about these SLAs when you look at them is you also have to understand when you're designing your system how the SLAs combine together. So if I'm building a web application on app services that, let's say, has a 99.95% SLA, so that's 21 minutes of downtime, which is the SLA currently for app services, well, specific app services, not the free ones. And I'm using a Azure SQL database that has 4 nines in the SLA, so that's 21 minutes and 4 minutes. My system could be down for 25 minutes in a month. When the app services are down, that's a different time than when the Azure SQL database is down. I could be down for 25 minutes a month. Microsoft would still be meeting their commitment, and I have to understand if that's good enough for my application. How many customers could I lose? How much revenue could I lose if it's down for 25 minutes? And the interesting technology choices and design patterns come into play when you're trying to do better than that SLA. So you're trying to do something to mitigate when Azure SQL might be offline for a few moments. Those are some of the things we'll look at. We also have to understand, so when you're selecting which service to use in Azure, you want to understand what is the SLA for that particular service, and also what are some of the inherent resiliency features that are built into that service. Because most things in Azure, they'll automatically give you some resiliencies. For example, with blob storage, when I want to store files somewhere in Azure, I can set up a specific type of redundancy in my blob storage. So literally, when you're creating a storage account, there's a little drop-down that says, do you want locally redundant storage? That's the storage that gives you 3 nines of availability, or 40 minutes of downtime per month. And every bit of data that you write into that type of Azure Blob Storage gets replicated 3 times in the same data center. It's guaranteed that your data will have copies on different racks of server. So if something catastrophic happens to a specific rack, like both power supplies go out or whatever, there'll still be another copy of your data inside that same data center. And then the interesting one, the one that's twice as expensive, is read access geo-redundant storage, where not only is your data still copied 3 times inside of the same data center, it's also asynchronously replicated to another data center that's somewhere else on a different continent, or perhaps on the same continent if it's a big continent. And if the primary data center if a whole data center goes offline, you still have access to your data from somewhere else. And we'll talk about how to take advantage of that. That's actually really easy to use read access geo-redundant storage if you use some of the Azure SDK libraries to access blob storage. For virtual machines, what is something inherent about virtual machines that will give you resiliency? That would be what Azure calls an availability set. So if I go into Azure and I provision a single virtual machine to run, there's no SLA for that. If I want guaranteed uptime from services that I put onto a virtual machine, I have to create at least 2 virtual machines, put a load balancer in front, and put those virtual machines into an availability set. And what an availability set will allow me to do, focus your attention down here, is I can configure how many fault domains and how many update domains I want in this availability set. So a fault domain is basically if something goes wrong inside of Azure, we'll try to limit the effect. So if I say I want 2 different fault domains and I want to create 2 virtual machines, I want them in 2 different fault domains. A fault domain is basically a server rack. So if an entire rack goes offline, the other computer, the other virtual machine I have provisioned should still be up somewhere in that same data center. And there's also update domains. So let's say I have 100 virtual machines provisioned across 3 different fault domains. There's also update domains. The update domain is Azure's way of guaranteeing you that even if they have to supply some sort of security patch to the hypervisor, the actual physical system that's running all the VMs, and they have to take everything offline, that your virtual machines will be distributed across these multiple update domains. They won't all go down at once to apply this update. And there's a very simple mechanism in the UI or with PowerShell script or however you want to do it to take your VMs and put them in these different update domains. If I'm building something with Azure SQL, there's a couple different ways to have resiliency if I'm using Azure SQL, which already has 4 nines of guaranteed uptime. One is replication. So it's easy for me to go in and say, this Azure SQL instance that I have running in an Australian data center, I wanted to asynchronously replicate all the writes and inserts and updates and deletes that I do into another data center, perhaps on another continent. And you can have multiple secondaries with Azure SQL. And it also provides point-in-time restore features, which there's a significant difference between replication and point-in-time restore. So if I have a bug in my application and it goes in and truncates a table or updates a customer table and sets everyone's name to Scott accidentally, it's a bug, Azure SQL will happily replicate that error around the world. And that's when I would need a point-in-time restore also. So you can configure those easily. This is a little interface where you can literally, here I have a Azure SQL instance running in the East US, and I can just click on another data center. The one in purple is the preferred data center for me to replicate my SQL Server into. And when you set up replicated SQL Server, you'll get to a little dialog like this, where you can make the secondary type readable, which has a number of interesting ramifications on your software design. If you have, say, a reporting system that hangs off the main application, it's very easy to point your reporting system to this replicated read-only version of SQL Server that kind of offloads things from your production system. Of course, that does mean that all the writes still have to go to that primary SQL Server, but there's automatic failover. So my primary SQL Server goes down, one of the secondaries will get promoted, my application will just fail over and start using that secondary. For app services, when we want to host web applications, one of the things that I can do with an app service to make it more resilient is geo-distribute it. That is, literally take my application and install it into different data centers around the world. Then the question is, which ones do my customers connect to? How do I route traffic to Australia versus one in the United States? That's something that we'll talk about here in just a bit too. So let's get into some specifics. Let's say I'm building a relatively simple application. I don't need a lot of resiliency. I'm not willing to pay for dedicating 10,000 virtual machines to maintain 99.99% availability. I just have my customers coming to an app service. My app service has an app service plan, which I'll talk about in just a second. Maybe I use just blob storage and Azure SQL. So I'd like to maintain some amount of availability in the system. And it turns out app service plans, which are what describe the virtual hardware that you're running on, if you're not familiar with Azure. So an app service is, here's my application. App service plan is, what hardware do I want to run it on? I might want to run it on a 2-core machine with 7.5 gigabytes of memory, or I might want to run it on a 4-core machine. But once I define my app service plan for my app service, I can also describe how many instances of that app service plan that I want. So how many copies of that hardware do I want? Do I want to run 2 instances? So if one goes down, I still have one available, or 4 instances, 10 instances. You can go up to 20, I believe, with app service plans, depending on the pricing tier you select. And Azure will automatically have a load balancer in front of you to distribute things across the app service plan. So that's a little bit of resiliency there. But I also need to think about the relationship between my app service and Azure SQL and using blob storage. One thing you can do in that situation is to take advantage of connection resiliency. So if I have an application that tries to reach blob storage or Azure SQL, and it doesn't connect on the first try and it just gives up, that's not very resilient, but it's also simple to program. If my application does, let's say, 3 retries with a little bit of back-off time in between, that can give me a more resilient application, because sometimes you just have those transient network conditions that don't let you through to a specific server. But if you wait, let's say 1,500 milliseconds, all of a sudden the connection will work. It turns out that if you're using some of the official Azure SDKs for these services like blob storage and for Azure SQL, these SDKs that are available for different languages, for JavaScript, for C#, they have built-in retry logic. You just have to take advantage of it and perhaps configure it differently if you want it to behave differently. So for example, Azure Storage, the official NuGet package from Azure, if I use that from C#, has retry logic. And here's a little bit of code where you can see when I connect to a blob storage with a blob client, one of the properties that is hanging off that object is the default request options. And I can customize the request options to say, my location mode is primary then secondary. In other words, I want you to try to go to the primary storage account location first, and if that fails, then try the secondary one. And actually, you have to do that if you want to have the 99.99% uptime guarantee. Microsoft says you have to try the secondary. I can also specify different retry policies. That is just a simple interface if I want to specify a custom retry policy, but this linear retry, which the default is exponential, by the way, we'll just try, it fails. OK, let's wait 500 milliseconds. We'll try again. We'll try that for a maximum of 3 attempts before we give up. For the entity framework and any framework core both provide an extension method, enable retry on failure, which is highly suggested when you're running inside of Azure, just again, because of the transient network failures that occur. So the entity framework knows about the specific types of errors that it might get back from an Azure SQL instance where it makes sense to retry that. So if you try to insert something that violates a constraint that's inside of a database table and the error comes back about that, Entity Framework's smart enough to know, well, if I try that again, I'm just going to get the same error message. But if it tries something and gets some sort of network-related error, then it knows, OK, we will wait for a period of time, 500 milliseconds, and we'll try that again. So those are some of the things that you can do that are really easy to have a more resilient service. Now let's talk about graceful degradation. This is where things get a little more interesting. I want to use a document database, Cosmos DB, whatever it's called this week, Azure SQL, blob storage. I'm not making that connection. The connection has completely failed. Now what do I do? Well, if it's a read operation, perhaps you have a cache with some older data inside of it that you could read from instead. And this is where there's a cost for provisioning resources in Azure. If I want the better uptime guarantees, I pay a premium for the better hardware, the better services from Azure. This is where you start talking about the cost of the software that you build. So now inside of my code, instead of having something that simply always just tries to go to the database, now I have to think about situations where, OK, if the database failed, let me try this other situation. So I start having some branching logic. And that not only increases the amount of effort that you spend in building your software, it obviously increases the amount of effort that you spend debugging things when something goes wrong and testing things to make sure you have all these different conditions covered and testing that this actually works. So what happens when I turn off my Azure SQL instance? I want to understand how the application is going to behave in that instance. It also depends on the type of system you're building, obviously, too. And that's where I can't give you specific advice about exactly what to do, but I can tell you that if you're building something that involves financial transactions or stock quotes, it might be a bad idea to serve up stale data, obviously. But if you're building some sort of social media site and someone updates the user profile and someone else can't read it right away, so we just show the old user profile that was in a cache, that's perfectly fine. What about writes to that database? Well, maybe if the database is down, I start using a queuing system instead. Or maybe I'm always using that queuing system and I have a backup for the queuing system. But one of the things that I want to point out here is that one of the best design patterns that you can have for resiliency has some other benefits too, is CQRS. So separating the model that you use for reads from the model that you use for writes, because you might want those things to take 2 different paths through your code. Use 2 different data access techniques, for example. Any CQRS fans? Good. Let's talk about a slightly more sophisticated scenario. So now I have customers. I have an app service. I'm using a storage account. I'm using CQRS. So I'm firing things into queues, firing things into blob storage. I'm using that Redis cache. I'm using Azure SQL, search services, App Insights, Key Vault, all these wonderful services. What I want to talk about is a couple different situations in that one. Whoops, no, let's do this one instead. Interesting. Let's talk about geo-distribution, actually. So I have an app service. I have a web application. I want to deploy that into multiple data centers, and there could be various reasons for that. I might want to deploy a web application into an Australian data center and a US data center just so that my customers from Australia have a server that's really close to them and the latency is low and the application performance is really good. And the US customers can use the US server. That might be one reason. Another reason is I might need a specific instance of my application running in a region for compliance reasons. So inside of the EU, I might want a specific installation of Azure SQL and my app service to keep all the information about EU citizens inside the borders there. What I can do with Azure is I can take the code that I deploy into Azure, and I can create multiple app services and deploy the exact same application into each of those app services, and then figure out which app service I will send my customers to using a service known as Traffic Manager. Traffic Manager is one of the load balancers in Azure, and I do just want to talk about load balancing for a second, because there's 3 different load balancers in Azure, and sometimes that gets a little bit confusing. First, if you go into the portal and you search for load balancer, one of the hits that will come back is the Azure load balancer. The Azure load balancer is a level 3 load balancer, so it operates at the TCP IP level. It's typically used in front of an availability set for virtual machines, because what you're doing is you're distributing TCP or UDP sessions across a number of machines. Another load balancer that is in Azure is the Azure Application Gateway. This is an application layer. It's layer 7, so it understands protocols like HTTP, HTTPS, and WebSockets. So it's a slightly more sophisticated, you could say, load balancer. This is the type of load balancer that is used in front of an app service, because I need a load balancer that is actually looking at incoming HTTP requests and looking at headers, perhaps for cookies, to implement features like sticky sessions. You know, once a customer has established a session on one of my servers, I always want it to come back there, which is not typically something you want to do for resiliency. And actually, if you create an app service with multiple instances of the plan, so you have multiple servers running, in Azure currently, there's a feature known as application request routing that is on by default. Application request routing is this load balancer injecting a cookie into the HTTP messages to make sure the client has a sticky session. I suggest you go in and turn that off and not try to use in-memory sessions. There's much better options that are easy to use these days. And then there's Traffic Manager, which I want to spend a little bit of time explaining. Traffic Manager actually works at the DNS level. So with Traffic Manager, what I will do is set up Traffic Manager with a set of rules that tells Traffic Manager how to connect my customers to one of these app services that I have deployed. It could be 10 different app services in 10 different countries. So when my web browser or my HTTP client or my operating system goes out and says, what IP address do I go to for ndcsydney.com, I'll have these rules configured in Traffic Manager to say, oh, because that's coming from an Australian IP address, we're going to give you back an IP address that goes to the Australian data center, that instance of the app service. And there's different rules that you can configure, but this is DNS resolution, basically. It's load balancing or sending my customers to specific locations by giving them back an IP address. The way this works is, let's say inside of Azure, I have an ASP.NET application running in the East US and the West EU. So East US and West Europe. Those would have 2 different domain names. So it might be musicsstore-us.com and musicsstore-eu.com. What I can do is go in and create a Traffic Manager profile. I can say, I want the domain name that my customers use to always be musicstore.trafficmanager.net. And yes, of course, you can purchase a custom domain and put it in there, so it could just be musicstore.com. You can purchase SSL certificates that get bound to that. And then with Traffic Manager, I pick a routing method. So when users come to, are looking for this site, looking for that IP address, what method do I use to return the IP address that they're going to use? One routing method you can use is performance, which is simply, given the current network situation, Traffic Manager will try to determine, given where that user is coming from, where can we send them that has the least amount of latency. There's also a weighted routing method. This is useful for a couple different situations. I could just weight things evenly. I could say send 50 excuse me, I'll slow down for a second. Send 50% of my traffic to this one, send the other 50% to this one. You can also do interesting things like if you want to roll out a new version of your software and just sort of test it out in production for a little bit to make sure things are sane, you can use that weighted traffic manager profile to say send 95% of my traffic here, but send just 5% of it over to this other app service so I can see how it behaves before I update the other app service with the latest features. And by the way, you can have nested traffic manager profiles. So I can have a traffic manager profile that points to another traffic manager profile that has another set of rules to do these same sort of things. You can also do priority, which is a good routing method if you want to have some sort of failover. So I can say this app service, priority 1. This app service, priority 2. Requests won't go to this other app service until Traffic Manager has determined that the priority 1 app service is in trouble for some reason. And by the way, this doesn't have to be just app services. I should point that out. With Traffic Manager, you can basically go to any endpoint. So I could have things going to app services in Azure, or a website on a virtual machine in Azure, or a website that I host in my own data center. And then there's geographic. That can be very useful for geofencing. So again, the situation where I have European customers, I want to keep their data in Europe. I want to make sure that all my customers that are in Europe go to a European data center. You can set up geographic rules to do that. Once you've created the Traffic Manager profile, then you can go in and in the configuration blade for Traffic Manager profile, where you can change the routing method if you want, you can configure the DNS time to live. That's important. That's 300 seconds right there. So that means if Traffic Manager hands out an IP address for an app service that suddenly goes down, my user could be waiting up to 4 minutes to get a new IP address to go to an app service that's working. And this is one of those settings that's just a balance between how quickly do I want things to fail over versus how many DNS requests do I want my users to be making. I think you can specify a minimum here of 30 seconds, but obviously then it's aggressively always asking for IP addresses. This endpoint monitor settings, so what we'll see is that I need to tell Traffic Manager about the different endpoints where I want it to send traffic, and then each endpoint that I provide, I have to provide basically a URL that Traffic Manager can go to figure out if that particular resource is healthy. So the path could be something like /status. A good recommendation would be to create a page or a route somewhere in your application that is dedicated to just returning the health of the system. And if you return anything other than a 200 response, Traffic Manager assumes there's problems. So you might have a dedicated status route that just checks. Do I have database connectivity? Do I have blob storage? Is everything online? If so, return a 200. Otherwise, return a 500. And Traffic Manager will realize that there's a problem there. And that path has to be the same for all of your endpoints, which are simply, for a Traffic Manager profile, I go in, I add endpoints. I say that this is one app service. This is maybe something deployed locally. But these are the 2 endpoints that I want you to balance the traffic between. So it's easy to use and effective. Let's also talk about load leveling. So another thing that you have to worry about to maintain high availability is when the crushing weight of a spike of requests comes into your system. How do you make sure that that doesn't overwhelm back-end systems? There's a lot of resources in Azure, like Azure SQL and Cosmos DB. When you provision them, you have to provision the request units or the data transfer units. Basically, how hard are you going to allow those things to work? And it's easy to end up in a situation where you have a spike of traffic where suddenly you're hammering SQL Server, Azure SQL so hard that you are exceeding the number of DTUs that you've allocated for that particular SQL Server, basically how much performance you're allowing for that SQL Server. And of course, you pay for better performance. So how do you level things out? I've been a big fan of Service Bus in Azure. It's worked really well. There's really 2 forms of queuing in Azure. There's queues associated with Azure Storage, which are very simple and straightforward and easy to use. There's also queues as part of Service Bus, which are also simple to use. But Service Bus provides some additional features like topics, which is basically a pub-sub mechanism. So I can drop a message into a topic and have multiple listeners, if need be. Or I can use queues and drop a message into a queue where one other service or one other thing will pull that message out and read from it. And Service Bus, by the way, easy to use. I can create queues once I've provisioned a service bus namespace, configure a maximum amount of size, configure how long a message should live in that queue, do things like enable duplicate detection, enable sessionings, enable partitioning. Partitioning is useful when you are creating an enormous number of messages, more than a single node would be able to handle. So you want to partition those things across multiple nodes. We'll come back and talk a little more about partitioning. But Service Bus, also basically easy to use. This is the official Service Bus SDK where I have a queue client that I'll create. I create a new instance of a brokered message where I can put some content inside. Maybe I can JSON serialize a complex object, put it inside the brokered message, and then just send things off to Service Bus. In addition to load leveling, there's also load throttling. One of the things I had to experiment with is if this company is going to provide a public API that people can use, how do I prevent people from abusing that API? How do I prevent people from making too many requests or writing some sort of, have a bug in their script that just is sending millions of requests to my API service every minute? There is a service inside of Azure known as API Manager. What API Manager can do is it basically acts as an API gateway. It acts as a proxy. What I can do with API Manager is create it. I can point it to the different services that I have, which might be in different app services or scattered across different virtual machines. And I can present a unified API to my clients. I can also present something that they have to register before they can use. And I can also easily implement policies like, I'm only going to allow you 5 calls a minute if you're on the standard plan. And I can have a premium tier for my API that allows them 100 calls per minute, but they have to pay more for it. So if you're writing an API that exposes metadata, either through Swagger or WSDL, it's easy to go into this API Manager and say, and point it to your metadata endpoint, and it will figure out what operations you have available. And this would be creating that API management service. So what's interesting about this, sorry if that's blurry, it doesn't matter how many APIs I have, how they're implemented, where they exist in the world. My customers can always just come to, let's say, scottallenapi.azureapi.net, or whatever custom domain I have, and I can give them access to everything that I have, no matter how it's deployed or where it lives. And you can see the different pricing plans and the different limitations here, but once I set that up, I now have two things. I have a management portal available to me, and I have a developer portal. So when someone from another company says, hey, I want to sign up to use your API, how do we get authorization tokens? How do I register for it? Azure already provides an API where they can come in, they can register with a username and password. They can then see the documentation for my API. They can then manage their own access keys. So it's just like when you go to use Google Maps or Bing Maps as a developer, and you have to register there to obtain an access token, an API key. That's all built for you. This is documentation that they would see. It's just based on your Swagger or WSDL metadata that API Manager gets. This is an example of how I can define products for my APIs, and I can place my APIs into different products. So I might have a starter product that is free. You have to subscribe to use it, but you'll only be able to run 5 calls a minute and a maximum of 100 calls per week. Or you can pay more money to get the unlimited product, have unlimited access to my API. So this is just a good way to control your API, to be able to monitor it, to make sure people aren't abusing it. I won't go into too much detail here, but inside of API Manager, you can set up policies. Policies are where you define things like the rate limits. It's all done through XML, and there's some simple policy statements here that you can drag and drop into the policy. And you can define policies at the product scope, at a specific API scope, or on a specific operation. And again, this is generally useful not just for load throttling, but also building APIs where the developers of the API might not anticipate what the customer wants. For example, things like cross-domain calls, or client might want JSON instead of XML. Since API Manager is basically a proxy, it can do some of those things for me. It can add CORS headers to the responses automatically for me, even if the original service doesn't provide it. Now let's talk about something completely different. I mentioned app services, I mentioned virtual machines. Let's talk about Service Fabric for a moment. There's a couple different ways that I could build a movie store application in ASP.NET. I could just create everything in one project, or I could take this microservice approach where I want the web UI to be a service, and the payment API to be a service, and the identity management for my application to be a service. And I have all these little different pieces and components that I want to build separately, and I want them to be able to be deployed separately and updated separately, but I still want them to function together as some sort of complete application. What technology can I use for that? That's one of the scenarios where Service Fabric can be interesting. So I want to give you two different perspectives on Service Fabric, and first of all tell you that Service Fabric is actually not tied to Azure in any way. Yes, you'll see Azure Service Fabric, but there's just some features that are built into Azure that allow you to provision Service Fabric a little bit easier. So two different perspectives. First, let's take the runtime perspective. The runtime perspective to Service Fabric is that Service Fabric is a technology that is designed to run services in a cluster of machines. So it understands that if you give it 5 machines to run on, and you describe the services that you want to run there, all those little services that I had on the previous slide, you can describe where you want those things to run, how many instances, how they should be distributed across the cluster. And Service Fabric will just make sure that, for example, Service A, perhaps, we want that to run on all 5 of these virtual machines. And they don't have to be virtual machines. Again, this is a technology where if I took the 5 or 6 laptops that are sitting around doing nothing in my basement and network them together, I can install the Service Fabric runtime on those laptops and set up a cluster. But you could also set up a cluster in AWS, and you could set up a cluster in Azure. So there's a runtime perspective that Service Fabric has, which is basically, I'm going to manage this cluster for you, and I'm going to try to make sure that services are always available. So if one of these nodes fails, if there's a catastrophic storage failure, or if something goes offline because a network card fails, I'm going to make sure that I take, let's say, these services, and if it's not running another instance somewhere, I'll make sure I move that service and get it running on another instance in this cluster to make sure it's always available for you. That's the runtime perspective to Service Fabric. And I'm just giving you the high-level overview. We could easily spend like 4 hours on Service Fabric. Then there's the programming model aspect of Service Fabric. So how do I write a service to run it inside of Service Fabric? Service Fabric has a couple different concepts. First, they have the concept of a guest executable. Let's say I write an application that's an ASP.NET Core or it's a Node.js application, and I want to be able to run it in a cluster of machines without my application having any knowledge of Service Fabric. You can do that. You just have to register a guest executable with Service Fabric. Tell Service Fabric basically how to start your application. Do I run a script? Do I run .NET Run? What is it? And Service Fabric will copy your executable to the clusters where it needs to run, and execute that command to make sure that service is up and running. So that's one approach to using Service Fabric, where your application has no dependencies on Service Fabric itself, the Service Fabric runtime. You're just a guest in that runtime. Then there's what Service Fabric calls reliable services. So these services are services that you're going to reference some runtime components of Service Fabric, and you're going to describe to Service Fabric when you're starting up, and Service Fabric's going to tell you when to open a connection. So your application and your service has to be able to interact with Service Fabric at a deeper level. And there's different types of reliable services. So there's a stateless service, and I'll show you code for this in just a moment so it makes it a little more concrete. A stateless service is a service that you register with Service Fabric, and yes, Service Fabric controls its lifetime and it understands when you're starting up, but your service doesn't have to store any state internally. You can still use SQL databases or document databases or whatever you want to use to store state, but Service Fabric doesn't have to worry about managing that state. Your application manages that state, or a database manages that state. And then there's stateful services. So these are services where Service Fabric provides you with a set of data structures known as reliable collections. So there's things like the reliable queue and the reliable dictionary. What a stateful service can do is, if it wants to hold on to a specific piece of information, let's say about a customer, it can ask Service Fabric for a reliable dictionary of a certain name and insert that data into that dictionary. So what's interesting about the stateful service is two things. First of all, those collections are in memory, so they're incredibly fast. If you don't want the latency and the overhead of going to a SQL Server database every time you need a piece of data about a customer, then a stateful service can be blazingly fast because all of that data is in memory. The second thing is all of that data also gets saved to disk, so that data is durable. So in addition to being in memory, if something catastrophic fails, there's still that state that's on disk for when the node restarts, and it's also replicated throughout the cluster. So if a single node does go down, we don't lose anything. There was a third thing I wanted to say, and it completely escaped my mind, but I'm sure it'll come back. The third thing actually was that it was replicated, so the state is replicated. And then there's also what's known as a stateful actor, which I've seen a number of people who implement things like real-time things like online games and online auctions. This is the kind of situation where I want an instance of my service per each user. So I go into an online auction to start setting up bids. The code that's running inside of Service Fabric is going to create an actor that represents me. It's going to put it on one of the nodes, and anytime I do something to modify my state or my bids or the things I'm selling, Service Fabric will be able to locate the actor object that's in memory somewhere associated with me and invoke a method or change the state or whatever needs to be done. And if I'm not present on the system, I stop using it for 20 minutes, Service Fabric also knows how to spin down that actor and bring it back up an hour later when I come back in. So to make this a little more concrete about what Service Fabric is, let's first do this. When you're developing with Service Fabric, you can install what's known as the Service Fabric Local Cluster Manager. That's a little orange thing that appears down here in my taskbar. I can right-click that, and I can say, there we go, I want to run a 1-node cluster, or I actually want to simulate a 5-node cluster here on my development machine. And if I go into Task Manager, I would actually see 5 copies of the Service Fabric executables and services running on this machine because I'm simulating a 5-node cluster. But if I just want things to be a little simpler, I could do a 1-node cluster. And there's an option here to manage the local cluster. So this is telling me that I have, in this cluster, which just happens to be on a single machine, I have 5 nodes, that five machines are running, 5 nodes. I have 1 application deployed to this cluster. You can deploy multiple applications. There's 2 services running. There's just 2 services in my application. And we'll talk about partitions and replicas here in just a second. But this application, movie store type, is just a web application, an ASP.NET Core web application that's distributed in that cluster and that people can reach with a browser just like you would with any ASP.NET Core application. But this particular ASP.NET Core application was not implemented as a guest executable. It was implemented as a reliable service for Service Fabric, which means it looks just a little bit different than your typical ASP.NET Core application. So if I come into program.cs, if you've done any ASP.NET Core programming, typically program.cs and the entry point for your application, that's where you create an instance of the web host builder and you start firing up Kestrel and you start listening reports and all of that stuff. With Service Fabric, that's not what you want to do. What you want to do instead when you start up is go out to Service Fabric and say, hello, you started this thing up, and this is your web type service. So that could be any arbitrary name there. But you're basically telling Service Fabric, hey, this is the name of the thing that's starting up, and when you need to create a new, or when you need to get that service running, just fire off this little bit of code that's in a Lambda expression. Basically instantiate this class, and that will contain all of the boot up logic for my service. So in ASP.NET Core, instead of starting to listen for HTTP connections inside of the main entry point, I instead have to wait for Service Fabric, which is now coordinating everything, to start things up. And it's inside of this web class where you will find things like the web host builder. Let's use a web listener or use Kestrel and configure our services and use the startup class and all those things you would see in Core. But notice that this happens inside of a method called create service instance listeners. So Service Fabric does want to be in control of your application. It does want to tell you when you should start listening to things, and actually please return to me a data structure that I can use to interact with whatever you're using to listen for network connections, which could be HTTP or TCP, whatever you want. But this basically starts my web application running. And again, it's an instance of a stateless service. So I derive from a base class to use this with Service Fabric. There's another excuse me, service that is running inside of this cluster. It's a service that the web application uses, and it's just a simple counter service. So we're going to spin up also in Service Fabric a counter type service that will start running when we invoke this class, and this class, excuse me, is a stateful service. So a stateful service is one of those services that Service Fabric can distribute throughout the cluster that's actually going to hold state in these reliable collections. So for example, what this service is going to do is something very simple. Just increment a counter every 1 second. I'll show you that code in just a second. But from the web application, I want to be able to go to one of my counter services and say, hey, what is your current count? You know, that would just be like, let's look up this customer and find out their first name. Right? In this case, I'm just doing something a little bit simpler, which is to get an integer value or a long value. What does that look like? Well, since I've derived from this stateful service base class, I inherit a property called state manager, and it is state manager that allows me to interact with reliable collections. So I either want to get or create a new reliable dictionary of string and long called whatever name, my dictionary. And once I have that dictionary, yes, these reliable collections are durable. They respect transactions. So if I write something into it and it fails without me committing, that'll be backed out. We don't necessarily, if I remember, we do need transactions even for read operations here, but this is basically me saying, hey, give me the counter value out of that reliable dictionary. And what I want to do is return that to whoever is calling this operation. What's a little more interesting is how we increment that counter. So when you write a service for Service Fabric, you can implement a method called run async. And in this case, what run async is going to do is just set up an infinite loop, so while true, and execute this code every 1 second. Every 1 second, it wants to fetch the counter value and then increment it. So again, go to the state manager, create a transaction, try to get the counter value in an asynchronous manner. We'll log some events here. Then we will try to add or update a counter value that has been incremented and commit that transaction. So that counter value is stored in memory. That counter value is persisted to disk. That counter value is replicated across a couple other nodes. I can configure how many nodes it's replicated across. And I do want to point out one of the tricky aspects of Service Fabric is that when you implement stateful services, you have to think about how you're going to partition your data. If all of your data can fit on a single VM, because remember, this collection has to fit in memory. So if I provision a cluster of 5 machines that have 3.5 gigabytes of memory, there's certain physical limits on how large my collection can be on that machine. If all my data, let's say, is 500 megabytes, I don't have to worry about things too much. But if I have 10 gigabytes of data, I need to figure out how to partition this service so that my data is spread across multiple nodes in the cluster and multiple instances of the service. And there's ways to describe to Service Fabric how to do that. I just want to show you something, which is a configuration file which you need to provide to Service Fabric, this application manifest, where I can say things like the counter service, I want it to have a partition of 1 or 10 or 20 or 100. You know, how many instances of the service do I want running across how many different machines? And I can also describe how to partition things. So you can partition things by hash codes. You can partition things by just simple integers. Let's say you're building an address book for the world, and you need to partition the names of everyone on the planet. You might choose a partitioning scheme that uses the first 2 letters of the last name, something like that, but you have to spread these things around, right? Let's see how we can use that counter service from our web application. Just want to show you that bit also because it's interesting. Let's go to the home controller. I just inline this code. So when the user comes to the index action for this particular web application, I want to go out and contact that counter service, actually all the counter services that might be running, which is actually kind of rare. Typically, you just want one, the partition that holds the data that you want. How do I communicate with other services inside of Service Fabric? There's a couple different ways to do it. One way to do it is using domain name resolution services that Service Fabric provides and just using HTTP or something like that. But you can also use this technology that Service Fabric calls remoting, which is, sounds like remoting from the old days of .NET, which nobody really liked that much. But in a way, it's similar. First of all, inside the Service Fabric cluster, I have pseudonyms for my services. If I want to get access to this counter service, I don't want to specify an IP address or a machine name or anything like that. So I'm basically going to build a URI that says, hey, on the fabric, in the movie store application, because there might be multiple applications, I want to find the counter service. That's what I want to connect to. And I can use this URI and call a Service Fabric API to say, give me that service. And what I will do also is on this Fabric client that I've injected, which gives you information about your environment, there's something called the Query Manager where I can basically say, for this service, this counter service, give me a list of all the partitions that are running in this cluster. And what this is basically just going to do, this little loop here, is it's going to loop through each partition that's available. It's going to use this class called Service Proxy to go out and create, or it's not actually going to create, well, it's going to create a proxy, but it's going to get a reference to one of those running instances of the counter service that's out there, given a particular partition key, and I can get the count value that's inside. So now I know if it's a 4 or a 5 or a 100 or something like that. I'm just going to collect those together inside of a dictionary and spit them out on the page. So I do want to show you over here in the Service Fabric Explorer, inside of the movie store, there's the two services that are running, my counter service, which is stateful and partitioned, and the web service, which is stateless, because it just uses the stateful services to store everything that it needs. And I can see inside of here things like where this is running. Now, in a real cluster, let's say that's running on Azure, I would probably run a stateless server on everything in the cluster, every machine, just because it's easy to do that. Counter services that are partitioned, this is showing me there's 3 instances of the counter service because it's been partitioned. Each one holds a certain range, data for a range of values, partition keys. And I can see the primary for this particular service instance is running on node 3 in my cluster. So that's where all the requests would go to when I want to get the count from that particular instance. They would go to node 3. But just in case there is a disaster and a machine blows up, that is also replicated on node 2 and node 4. And so if I actually come out here and look at the nodes that are running, is that visible in the back? Try this. Let's go out and look at node 3. And there's a little option here to, let's do a restart on that node. Node 3. Let's come back up here. What Service Fabric should detect here in a moment is that something is wrong in the cluster. And what it should do, if we watch here, hopefully it'll happen. There we go. The primary is now node 2. So Service Fabric switched, when it detected that node 3 was offline, went to a new primary. It'll bring node 3 back up online here in a bit, and that'll still be an active secondary, but you can see the question mark there, right? And that's Service Fabric's whole purpose in life. Make sure everything is up and running and always available, no matter what you're putting out there. Another interesting thing about Service Fabric that I want to point out, down here at the bottom, they have a chaos monkey built in. So Service Fabric itself, sort of a collection of microservices that run on the cluster. There's a cluster manager service, the DNS service, the failover service. It's the fault analysis service that's actually interesting. It's up and running in there. And it provides an API that allows you to take nodes offline, restart them, destroy things, restore things. It's one of those things that you might want to use when you want to test. How does my system behave when a node goes offline? Make sure that everything works properly. And finally, what does this look like in Azure? Or what does Azure offer for Service Fabric? Some people get a little overwhelmed by the configuration, but it's not too bad once you've gone through it a couple times. And hopefully you'll automate it, right? So you can do this all the time. basically with Azure, you can say, yes, I want a new Service Fabric cluster. Here's the name. This is the URL that my users would use to connect. This is the operating system that I want to use. This is going to go out and provision the virtual machines for you. Could be 5, could be 100, could be 1,000 virtual machines. They're all going to have the same username and password. They're going to be set up inside of Azure in something known as a virtual machine scale set, which just is something that makes it easy to manage this pool of identical virtual machines, hundreds of them if need be. Once you get through that simple configuration, you do some of the standard things that you always do in Azure, like choose a size for the VM. Whoops. You might want to go with a 4-core, 14-gigabyte version because you want to have reliable collections that have a little more space to breathe inside of each node, for example. And you can set up things like autoscale. All of that's available. Once you complete that, everything is provisioned for you, and you can go in and manage your cluster and deploy to your cluster there. Before I leave that slide, there's a couple things about Service Fabric. I evaluated it quite heavily at the beginning of the year, and I will tell you we decided not to use it. We decided to stick with app services. I think Service Fabric is a perfect technology for some specific types of applications, particularly applications that deal with real-time data, applications that need really low data latency, things like games and online bidding sites and things like that. But I can also tell you that trying to get a development team up to speed on this takes a little bit of time because it's a different programming paradigm. It's a different way to think. And I think the partitioning is particularly tricky. You have to kind of figure out up front, using part art and part science, how big is my data going to be? How am I going to partition it? What sort of strategies am I going to use there? But it is certainly a technology that is quite useful. I have heard a statistic that something like 60% of the cores in Azure total are running Service Fabric because a lot of the Azure services themselves are built on top of Service Fabric. Azure SQL, Cosmos DB, a lot of the Bing things and Cortana things run on Service Fabric. So it's certainly a technology that Microsoft dog foods and uses itself. A couple obvious things. If you want high availability, you have to automate. I have this rule with the development team that I work with. If you're going to make a change in the development environment or the QA environment or the production environment, I don't care what environment it is, you're not allowed to use the portal. I want to see a script for that change or an Azure Resource Manager template. Azure Resource Manager templates are wonderful. If you haven't used them, they are JSON files that you can use to provision anything in Azure. You want to create an app service, a virtual machine, a SQL database, you want to buy a DNS name and attach a SSL certificate. You can do all of that with Azure Resource Manager templates, but they are also one of those technologies that can be a little bit frustrating because they aren't always well documented. Sometimes the best way to figure out what you want inside of this JSON file to instruct Azure what to do is to go out and look at a sample or else do it in the portal, and the portal will allow you to export a template. So if you're new to Azure, definitely look at Azure Resource Manager templates as a way to automate Azure. Do all of your change through that because you can check those things into source control and parameterize them. They work great with secrets like passwords. You can pull them out of Key Vault. It works very well. Another thing that should be obvious is you need to do some testing to make sure that you do have high availability and things are behaving well under load. We use the load testing tools that come with Visual Studio, but there's a lot of different ones out there. And monitoring is also one of those things that you have to have. Azure provides some pretty interesting monitoring tools, and they provide services like Application Insights. If you haven't used that, I would recommend using that for some of your diagnostic syncs. But for complex systems, the monitoring that Azure provides, it's not customized for your domain and for your business. And for large systems, I would recommend also taking a look at building a custom monitoring portal of some sort where you pull information from Application Insights, you pull information from some of your application audit logs to really be able to drill in quickly on how your application is actually performing and what sort of load it's experiencing. It saves a ton of time because when things go wrong and you find yourself clicking on things randomly in the portal, trying to find something that tells you exactly where the problem is, it's very frustrating, and when you're doing that under pressure, it just makes for a bad day. I've been there. I have more information in a more structured format than this rambling presentation in my Pluralsight courses. I think I have 14 hours of courses covering Azure, including some of the topics here, and a little bit better explanation of Service Fabric. So feel free to go there if you'd like more information. You can also email me or contact me on Twitter. And I thank you for attending and hope you have a good day.